Okay, so we're now going to go back and fill in the remaining steps of this history-based approach to parsing. Remember, the first step is to somehow represent trees as sequences of decisions, and that's what I've just shown you on the previous slides. The second step is to say that the probability of a tree is, by the chain rule, a product of terms where at each point I condition the ith decision on the entire sentence as input and the previous I-1 decisions. So the remaining steps of this approach are going to be to derive a log linear model that estimates these conditional distributions, and finally to somehow implement search for the highest probability parse tree. So let's talk about this next. How do we use a log linear model to define this conditional probability? So the basic idea is rather simple, actually. Following the usual definition in log linear models, this conditional probability is going to be e raised to the power f dot v, where f is some feature vector and v is some parameter vector, divided by a normalization constant where I sum out all of my decisions. So notice here I have f, which is a feature vector that looks at a history in combination with the outcome. We also looked at bigram features, which might join information here between these two constituents, or here between these two constituents, or trigram features, which would look at three sequences of label 3, where we might look at the three non-terminal labels along here, or the three non-terminal labels here, or the three non-terminal labels here. Finally, we might look at various punctuation features, because punctuation is often very useful in parsing. Things like commas, colons, semicolons, the presence of those in the neighborhood of a decision can be quite useful in disambiguating these parse trees and in deciding which decision to take. So this is really just a sketch. The main point I'm trying to get across here is that when we make this decision, join or start, at a particular constituent, we can employ quite rich representations of the context surrounding that decision. For the check decision, there are two choices, either check equals no or check equals yes. And so we might, for example, if we had check equals yes right at the start of the parse tree I showed you earlier, we might have constructed this parse tree here, which is actually a rather bad parse tree fragment. Whereas, so this is check equals yes. If I'd chosen check equals no, I would have left this as a start S.